Hi everyone, my name is Thomas Kim. Today is April 9th, 2019. This is my 7th episode about automata theory and implementation in C++. In this episode, I will demonstrate how to generate transition diagram for DFA and NFA. We will be using our previous source code, so if you haven't watched my previous source code, please double click this link. Also from this episode, click Show More. At the bottom, double-click this link to download our previous source code. To follow this session, we need to install graphviz. Please double-click this link if you haven't installed it. From this website, download, then you can click Stable 2.38 Windows Installer Package or this package. You can download and install graphviz, graph visualization software on your machine, because we will be using this software. In your download folder, please unzip it, rename it Finite Automata Transition Diagram. Transition diagram. Copy the folder, paste it to your working folder. Double-click the folder path, copy the folder path, start Visual Studio 2017. Go to File, Open, Project, paste the folder path, enter, then select Finite Automata Solution. Open. Right-click the solution, add new project, Visual C++ Windows Desktop Wizard 06 Transition Diagram. Click OK, click OK. Right-click, Start a project, right-click, Properties, select all configuration, all platform, C++, language, C++ 17 standard, apply. General, additional include directories, edit, click this button, solution, dir, include, enter, click OK, click linker, general, edit, copy this text, copy, scroll down, build event, post build event, edit, paste, enclose with quotes like this, angle bracket, dollar, project dir, output txt, close quote. Your evaluated value should be resolved like this. Click OK. Apply. OK. Right-click the header files, add the existing item, go up, include, automata, add. Double-click PCH, include, talk platform, automata. Save all, close this. Now we will copy some code from our previous episode, first episode. Double click this file. I will copy all, Ctrl A, Ctrl C, copy all. Then select this part, Control B, paste, scroll up. I will remove this part like this. Then Control F5 to test. Your program should run like this. Close it. Right click the project. Add existing item. Go up. Select our project folder. Click output. Then this output file is generated. Now here we will remove some files from here. Delete. This function survived. This function survived. So all squiggled part is deleted. This is deleted. And this is deleted. So I will delete all. Control F5 once again. Okay, it should run successfully like this. This is from YouTube. I will copy this URL, copy, and paste it here.
In the last lecture, I have given you the theoretical explanation.
This is minimization of DFA example. I will use this video as our sample. This is the minimization sample. Here we will display DFA like this. Stream, generate, transition diagram, NL, stream, DFA, diagram, digraph to string, NL2, like this. Now we build it. We will create one more here. Stream, minimize DFA diagram, NL, stream, minimize DFA digraph to string, NL2. It should be NL2. Control F5. This is transition diagram. No, not this one. This one. Now open this file. Then we can copy this part. This is generated. Copy. We can copy this part. I copied, and we start search gv edit. This is a package included in graphviz. Click it. Click new. Paste the code here like this. I copied and pasted. Press F5, or you can click this button, or you can click this button. So this is a diagram before minimized. We can also display like this. This is the same diagram but with a different perspective. This is the diagram of this. So A is start state. When A gets input 0, then it transitions to B. When A gets input 0, it transitions to B. When A gets 1 as input, then it transitions to C. When A gets input 1, it transitions to C. In C, when it gets 1, it comes back to C. In C, when it gets 1, this is 1, it gets back to C. And in B, when it gets 0 as input, it gets back here. And E is accept state. This is the transition diagram before minimization. Then here, after minimization, this graph is created. This is minimized graph. This is converted, copy. Then we paste it here again, like this. Then you can click this button. It is converted like this. We can have different view. Select dot, click OK. Then it will be generated like this. This is minimized transition diagram. We can compare it with this video.
Of me to 1. Okay, now.
So E is here. When E gets input 0, it transitions to B. E gets input 0, it transitions to B. When this is E, when E gets input 1, it transitions to AC. When E gets input 1, it transitions to AC. At AC, this is start state, this is accepting state. At start state, when it gets input 1, it transitions back to AC. This state, when it gets input 0, it transitions to B, So this graph are actually identical. They are exactly identical. We can try with different format. So this diagram is closer to this one. It's a little bit more clustered. It's better to analyze. Now we try another one from this program. This is another minimization example. I pasted it here.
In the previous lecture, I have taught you about minimization of DFA.
In this example, they do not provide transition diagram, but we can still create transition diagram. If we see output here, this is the DFA. This DFA is actually this
so again,
one.
It is fine.
Say 0, symbol 0, 1, 0, 1, 1, 5, 1, 5, 6, 2, 6, 2, 0, 2, 0, 2. These are accept state. The 2 is accept state. So this is exactly the same DFA. Then we can generate its graph like this. Here, we can generate DFA like this. Stream DFA diagram, stream DFA digraph to stream, NL2. After minimization, stream minimized DFA, NL stream mini DFA like this, NL2. Now we run it, Control F5, close it. Output is updated. This diagram is this. Copy, paste, then click this button. So we have a transition diagram like this. This diagram, transition diagram, represents this transition table. If we play a little bit more,
hence we can say, okay, now Q20, Q4, and on getting input 1 it goes to Q2. So here I have the minimized DFA for this.
So this is minimized DFA. This is minimized DFA. We can copy, paste it here. So this is minimized DFA. Now we can compare this with this result. So this is initial state Q0, 4. 04 is start state here. This is Q3. Let's see.
DFA. So in the original one we had 8 states, but here I have only 1, 2, 3, 4, 5 states. And if you check the working, you'll find that both the workings of these DFAs are exactly the same. So this is
okay. This is Q2 is the accepting state. So Q2, this is 2. Q2 is accepting state. This is transition diagram after conversion. In case of 4.0, when at start state, when it gets input 0, then it transition to 1.7. 1.7. When it gets 1, then it transition to 3.5. 3.5. And in this state, in accepting state, when it gets input 0, then it transition to 4.0. This is 4.0 start state. In accepting state 2, in this state, it gets input 1, then it transition to Q2, this state. So this transition diagram is created. Now we can have another more complex example. We can also try this one, like this. This example, NFA to DFA conversion, exercise 233, page 66 from this book. We initially create NFA like this, then we can draw stream transition diagram for NFA, NL, stream, NFA, digraph to string, NL2. Then you can use full subset construction to convert to DFA like this. Stream converted DFA using full subset construction. NL stream, we need to create here, save here, auto con DFA. I copied and pasted it here. Then copy, then paste here, con DFA, digraph to string. Now we can use another subset construction method, auto compact DFA. Copy, paste it here, and copy this stream converted DFA using compact subset construction. NL stream compact DFA digraph to string NL2. Now Control F5. We close it. It is updated. So this is the diagram. Please note that this is NFA. Paste it here. Control F5. So this is NFA. These are accepting state. Let's see why it is NFA. In case of state Q, when it gets input 0, it transitions to S. When it gets input 0, it transitions to R. So this is NFA. And this NFA is subset constructed. This NFA is subset constructed using full NFA. This one. This table is created. Then this diagram is drawn. Copy. This is converted DFA. Converted DFA using subset construction. Ctrl F5. It is drawn like this. It's huge. Okay. We can use compact subset construction this way. I can copy this part. Copy. Ctrl A, Ctrl V. Then Ctrl F5. Then it is reconstructed. This is more optimized way. This is DFA converted from NFA. In class view, talk playpen DFA, you can use digraph to string. This function generates the graph using these internal functions. You have complete source code. In future sessions, I will discard all this source code and I will re-implement from scratch. To implement this algorithm, we need to implement quite a lot of algorithm. I decided to remove all this code and I will start from scratch. And I will also give you complete documentation in future sessions. If you follow this video, you can create complete application using these libraries that I will implement from scratch with complete documentation. Please subscribe to my YouTube channel. Thank you for watching.